We all depend on interconnectivity to get things done. Our phones, our cars, wearable technology, and at our jobs, especially if they're technical jobs, it's amplified. It feels like everything has to be integrated. There's APIs, platforms that need to talk to systems that we never touch. But in some industries, there's a desire, or more like a need, to have everything locked down, isolated. That's because those industries may deal in sensitive information, data that a hacker would drool over. But these environments still need to do the same things that other environments do. They still need to store and manage that data, ensure its accuracy. They still need to provide space for developers to create and innovate. But how? And what is it like to work in that type of environment?
This is Compiler, an original podcast from Red Hat. I'm Angela Andrews.
And I'm Kim Wong.
We go beyond the buzzwords and jargon and simplify tech topics.
Today's episode, we're connecting the dots on disconnected networks. Angela, in the spirit of being accurate, I spoke to someone who has expertise in disconnected networks.
Ooh.
Yes. I spoke to Josie Pfeiffer, a Red Hat consultant. She's based in Europe. Josie focuses on infrastructure and security. She works with customers who use disconnected OpenShift clusters.
A disconnected OpenShift cluster is basically an environment that isn't directly connected to the internet. So you can also call it air-gapped.
Air-gap. Does that sound familiar, Angela?
That is the word. That's the buzzword. Air-gapped.
Yes. I'll admit, I didn't know a lot about air-gapped networks when I was going into doing this episode.
Okay.
So I did some research and I found a great article that was written actually by another Red Hatter, architect Stephen Wilson.
Ooh.
I'll read from the article. An air-gapped network is one that is self-contained but has no external or internet connectivity. Networks are often air-gapped as an extreme security method for government or corporate projects that require confidentiality or secrecy.
In a nutshell.
Yeah.
That is a perfect definition for what an air-gapped network is. The level of security and privacy that you need for an environment like this must be high. You cannot have some sort of external threat coming into your network. So you have to cordon it off in such a way that everything works within, but nothing from the outside gets in unless it's absolutely purposeful and with very good reason.
Right.
Usually via SneakerNet.
SneakerNet?
Do you remember SneakerNet?
No.
Baby, wait, let's go back. Okay.
All right, let's go all the way back.
So I know our listeners here, when they hear the term SneakerNet, some of them are saying, oh, I remember SneakerNet. And then we have some folks that are like, oh, what's SneakerNet?
Okay.
So back in the day, when you wanted to take a piece of data or file from one machine to another, and maybe they weren't networked, maybe they were, but they weren't on the same, whatever, you would get up and your sneakers would walk across the floor and you'd have your little floppy disk in your hand and you'd go stick it in the other system. That's what SneakerNet is.
Oh, wow. Okay. So you're just like hand walking it from one computer to another.
Basically.
Okay.
And I did say floppies.
Yes, you did say floppies. Wow. Okay. So, all right. I get that. And that tracks with some of the things I was reading about air-gapped networks. Okay. All right. SneakerNet. Okay. I learned something today. I think I understand what a cluster is, right? A cluster is a group of nodes that are like working together in an environment, right?
That is correct.
And now we know disconnected network or an air-gapped network is a self-contained network that doesn't connect to the internet or any other outside network, right?
That is correct.
So what's the difference between a disconnected network and a disconnected cluster?
Well, this is me guessing here, but a cluster is disconnected if it lives in a disconnected network.
Right.
So it can be clustered, meaning it's sharing network and storage. Like it's sharing resources together.
With other clusters that are in the same network.
You can have a cluster in one network and a cluster in another network, and never the twain shall meet.
No, and it's something that's only done when the utmost security is needed.
So it's not something you just do for fun. It's mostly just because these organizations are highly regulated. So financial services companies or insurance companies, any sort of organization that handles sensitive data, also like healthcare, for example.
But here's the thing. Many of the same things that are in a regular, more like open network or a network that's connected to a cloud server, for example, also need to be in an air-gapped network. You still have the same things that need to be done. Does that make sense?
The same bells and whistles are happening in disconnected networks that they are in regular networks that are connected to each other and the internet.
Right.
That is correct. They still have to do the thing.
They still have to do the things. They still have to store data. They have to still do file sharing. That's usually done in TFTP or Trivial File Transfer Protocol. It's handling file transfers between a server and a client in a disconnected network. There's other components like web servers, DNS, etc. But what are the difficulties here? Josie says for the OpenShift cluster itself, there's the inability to get updates from an external source.
The cluster can't phone home, so to speak. You, for example, can't get upgrades that you can just pull from our official Red Hat registries. The customer would then have to operate their own internal registry that the cluster can connect to. You want to usually have the latest and greatest in terms of security updates to make sure that you're not running a system that has known vulnerabilities in it, and you want the latest features so your engineers are happy. And there are two big things that you need for that. There's the platform upgrades, that is just to run the basic OpenShift. And there's the catalog, which is for operators. It's basically like the App Store for OpenShift, where you can install all kinds of add-ons that run on top of OpenShift and that add more functionality to the cluster.
Okay, so in a disconnected environment, you still need to have updates and the latest and greatest operators and things of that nature. What an individual would do in a disconnected environment, they wouldn't say, oh, well, we're disconnected. We are unable to perform these tasks. No, you're doing this your own version of SneakerNet. Instead of to your next door neighbor, you're going to Red Hat and you're downloading this latest version or this image. And what you're going to do is you're going to check the hash.
Okay.
You're going to make sure that the contents that Red Hat has said, this is what you're downloading, you're going to confirm that when you download it. You're going to make sure that that's the exact same hash that Red Hat has said. If anything has changed, say there was a man in the middle, there was some sort of nefarious behavior, and you download said package and you ran the hash and the hash was different, you'd never use it. So there's this level of checking that you would have to do when you downloaded anything from somewhere else to bring it into a disconnected environment. You'd have to make sure that the integrity of said files would be what they said they were. The integrity was still intact before you brought it in to your disconnected network.
Maybe we can try an analogy. So let's say you did order something from Amazon and your package arrives at your doorstep. And then you might look at all the edges and you see if someone peeled off the sticky tape on it. And that is basically the integrity check. It's just seeing if someone tampered with the package and if it's still okay to deploy into the cluster.
Well, the need for that layer of security is clear to, well, you, me, Josie, a lot of people listening. But just in case it wasn't, there's plenty of rules and compliance steps to ensure that things are kept locked up pretty tight.
For financial services companies, for example, there are regular audits where they need to get the rubber stamp that they're compliant with certain standards.
And that's a tricky part because different countries, different standards, different regulations to follow. And the punishment can be severe for companies that fail to meet the criteria.
So Switzerland, for example, also has a strong national regulatory body that imposes additional requirements on top. And the consequence of not meeting them can, for one, be financial. And so there could be fines if you don't meet them. And it could also mean that if you're a bank, for example, that they revoke your license to operate as a bank.
High stakes.
Yeah, very. But that's good, right?
Mm-hmm.
Well, if you're an avid online shopper like me, it is. It's good to know that these networks are in place. They're protecting your information. But how does one ensure the data handled within a disconnected network is accurate if it's not able to connect to another service to ensure that accuracy? People aren't static, and neither is their information. A network doesn't just sit on the data. It needs to move it around, use it, process it, update it when it's needed. Josie breaks down the concept of mirroring, something that happens often in disconnected environments.
So mirroring is basically just taking something that exists in this public registry and putting it one-to-one into your internal disconnected registry. Then it will take the release images and operator images from our official Red Hat registries and will mirror them to an internal registry. The cluster will expect things to be at the official Red Hat registry location, but through that mapping, it can then find them in the disconnected registry.
All right, so this internal registry, what mirroring does is, since it can't get information from outside the network, it's taking something that exists and putting it into an internal disconnected registry, and then the cluster will find and correctly identify data through mapping to that local registry that's on premises.
That sounds about right.
Bam, I got it.
It tracks.
Yes. Okay. Well, disconnected clusters, air-gapped networks, they're restrictive for very good reasons. But as things keep changing in tech, should that change how we think about them? Up next, we further examine the need for air-gapped networking and find out how shifts in available tech may affect our feelings around security versus innovation. Sit tight, we'll be back. We left off with Josie explaining the functionality of disconnected OpenShift clusters, but it made me think more broadly. It all seems safe and invisible to bad actors, but at some point, the data needs to be transferred into a public cloud or some other network in order for it to be used effectively. And there's still a layer of security there, something that many of us are familiar with: encryption.
Whenever you go on Amazon and you put in your card details, for example, and it goes through some payment processing service in the background, that service will likely have to pass a PCI audit to be allowed to process your card data, and they have to show that they're handling your data in a secure way and that they have encryption in between in the network to make sure the card numbers aren't just legible for anyone.
But that's still a point of vulnerability. The data is moving from this super secure environment to a service. Won't attackers just kind of congregate in places where the air gap stops and the services begin? It kind of reminds me of Command Line Heroes. Season 8, we did the season on malware, and a lot of the attacks that we covered in that season, they all took place at kind of like the point that's nearest the user themselves. And that's because with a lot of the experts we talked to for that season, they said that that's kind of like the point of vulnerability that a lot of bad actors identify. It's not necessarily these like, you know, people have this kind of very like glamorized image of hacking where people are hacking into these super secure environments. But in all actuality, these people are very smartly, if you're thinking about it, they're going for the weakest link in the chain.
You couldn't have said it any better. It's literally the weakest link in the chain, and it's usually the end user.
Yep.
You know, the company that has their data moving in this air-gapped environment, they can't control what's happening on a client.
No.
So the best way to do these nefarious things is the low-hanging fruit.
Yeah.
Go to the end user. They don't have what these huge environments have. They don't have the networking team and the security team and the DevOps team and the OpenShift team. They don't have all that. They have their little computers and, who they bought them from gave them 90 days worth of antivirus and spyware. So we're just trying to do our best out here. Definitely the weakest link.
Yeah. And there's the issue of convenience and ease of use, right? The data in these networks and clusters are used for businesses that need to be able to move fast for customers that aren't as security focused. I know for me, I just want my shoes. I don't really think about, PCI and I mean, I should.
And you shouldn't have to.
Well, no. As a technologist, I feel like I should. But as a consumer, I just want my shoes. I'm not really thinking about the part that security and encryption and disconnected networks play in my online retail therapy.
And you just said a lot right there. We should be thinking about it because we are putting our information, our financial information into some box on a browser, right?
Yeah.
On some network. If we're home, we probably have a little bit more security. Heaven forbid we're sitting in a coffee shop on some free Wi-Fi without a VPN. Don't get me started
looking
there.
Looking to my left, looking to my right, trying to avoid your gaze.
Exactly. We have a part to play. The URL. Is it the little lock on it? Is it encrypted? That's a small part. Do we have a VPN on?
Right.
Are we better off using our phone as a hotspot as opposed to using some free Wi-Fi, on the back of a refrigerator somewhere? We should be more mindful of the part we play in securing our data.
I want to step even a little bit further back from the end user or the end consumer and talk about businesses and people who are providing services directly to users. If you have a store, if you're selling the shoes to me, if I'm buying the shoes from you, how much knowledge and how much kind of consideration should you be giving to these types of situations?
That's interesting because now there are a lot of companies who focus on just that, on the transaction, on moving money from one person's account to another. And those businesses are hired by maybe the smaller business to take some of the onus off of them. So are we writing the code for protecting people's data? No, we're going to enlist the help of someone else. But there are things, me as the small business owner, what can I do?
Right.
Are the systems that are running my whatever, are they up to date? Are they on the latest versions of software? Are the workstations and kiosks, in my business, are they up to date? So there's a lot of moving parts and there are a lot of people who need to be a part of the solution as opposed to being a part of the problem and saying, well, not my problem. No, we all have a part to play in that.
I like that. Not passing the buck.
No.
Either to the customer or to a larger kind of enterprise level tech company. I feel like it's a shared responsibility when you're talking about security.
It is.
Yeah.
So when we want to do that retail therapy, we're going to make sure that the site that we go to and put in our credit card information is encrypted.
Yes.
We're not going to be like, this is such a deal and not do our due diligence and start typing in those 16 digits.
But Angela, my shoes though.
That's where things go wrong.
Yeah, okay, all right. I got to show some restraint. I have to put my own credit card information before these pumps that I really like. Okay, that's fine.
A little bit.
Okay. But, I started thinking about the future. And obviously, everyone in tech is always looking ahead, right?
Always.
Is there room for further advancement within an air-gapped environment? I imagine it to be, it's a restricted environment by default. What does it mean for technologists that work in these spaces? How can they be more innovative, looking forward?
The client I'm with at the moment actually is already experimenting with AI. And you can either create your own models based on the data in those disconnected systems and then use them in there. Or there are some really cool open source models that you can just put in there and maybe train them with data on top of that as well.
That's really interesting to me.
Yes. So again, if you're introducing something that's outside of your disconnected environment into your disconnected environment, there has to be some analysis and checking in place.
Vetting.
And as we're hearing about data and AI,
Right.
we need to know where this data is coming from, right? So being able to trust the source. How are we vetting? How is that being vetted? And because this is such new technology, there's so much more growth that's going to be happening. And we'll hear more and more about this as we go on.
Yeah. Josie thinks that that's a long way down the road. And to your point, Angela, this is all very new. We're not quite there yet.
I'm still a bit skeptical of how much can be automated directly with AI. If we think of like a very classic use case that a user opens a service desk ticket because something isn't working. At the moment, I don't really see AI being able to work with a lack of information still. So if I just think about some service desk tickets I generally get, it's usually lacking a lot of information and context. If I think I'm putting in a query to AI and I want AI to solve my problem for me efficiently without giving additional information, then I don't think that's very realistic at the moment.
So don't you worry. We're still going to need, at least in these disconnected networks we're talking about today, we're still going to need a lot of really great people to solve problems.
That's not going away anytime soon.
No.
If anything, this is a burgeoning field of study. This is where people can start making their mark and understanding how do we bring this new technology into these types of environments safely and securely with reliable data. And I think we're at the tip of the iceberg. There are going to be pretty smart people out there trying to solve this exact problem. And it's just a matter of time to see how effectively that problem is solved and in which use cases this can be used for. So stay tuned. We're not there yet, so everyone stay put. You know, we don't have to worry about the robots just yet. But know that we're always improving and heading toward what she's mentioning.
Before we parted ways, I asked Josie what she likes about working in these super restrictive environments, despite the difficulties and inconveniences. She says working around restrictions can actually help people to become creative problem solvers.
I think you have to be a nerd for it to be rewarding. You have to enjoy solving problems in interesting ways and using technology to find new ways to solve problems.
Josie is just the type of technologist that I absolutely adore.
Really?
They are creative.
Yes.
They're curious. They like to solve problems. And it's all about working smarter, not harder.
I didn't know a lot about disconnected networks or disconnected OpenShift clusters before I started digging into the research. And there's the cybersecurity kind of aspect. There's the aspect of environments for engineers and developers for innovation's sake. And how do we make sure that like people are security focused across not just a network, but also across an entire kind of ecosystem, an entire experience, like for a customer or for an end customer to have their data be protected. There's so much to dig into in this episode. The whole nature of it is kind of like a black box, and the sneaker net and the very kind of practical aspects of having these kind of lockdown, isolated systems, but then knowing that these systems exist to house data that's very sensitive, but there needs to be consideration for what happens to that data once it leaves that environment. I feel like there's a lot for technologists to still think about and discuss and still try to like wrap their heads around, even though I'm sure that systems like these have been around for forever.
I'm sure there are a lot of our listeners who aren't familiar with air-gapped environments. And this is their first foray into this topic. I'm hoping we have listeners that work in these air-gapped environments and they have a lot of experiences that maybe even those who work in traditional environments, they can probably share it. So I'd like to hear from both sides. What are your thoughts on this episode? My folks working in air-gapped environments, what are some of the behaviors that people in traditional environments could take from air-gapped environments? Anything that you've listened to and learned and enjoyed, or maybe eyes were open to, we'd love to hear it. So hit us up on our socials at Red Hat. Always use the hashtag Compiler Podcast. Let's talk more about these disconnected environments. I'd like to hear what you have to say.
And if you are a part of the team that protects me and my data while I'm shopping for my shoes, I salute you.
And that does it for this episode of Compiler.
Today's episode was produced by me, Kim Wong, with Johan Philippine and Caroline Craighead. Thank you to our guest, Josie Pfeiffer. And a special shout out to Stephen Wilson. His article on disconnected networks helped shape this episode.
Victoria Lawton loves a good integrity check.
Special thanks to Britt Dugan. Our audio engineer is Christy Chan. Our theme song was composed by Marianne Chetta.
Our audio team includes Brent Semino, Lee Day, Stephanie Wunderlich, Mike Esser, Nick Burns, Aaron Williamson, Karen King, Jared Oates, Rachel Ertel, Devin Pope, Mike Compton, Ocean Matthews, Paige Johnson, Alex Trabulsi, and the mystical Mira Cyril.
If you liked today's episode, please don't keep it to yourself. Follow the show, rate the show, and leave us a review on your platform of choice. Share it with someone you know. It really helps us out.
Thank you so much for listening. We'll see you next time.
Yeah, we'll see you on the sneaker net. Bye, everyone.
See you, everybody.